In hospitals and labs, portioning out food or medicine has taken separate devices to help with recipe preparation and evaluation, which increases the process and delivery time. Gathering required materials in the workspace during recipe preparation leaves less space for a scale and cutting board. A sponsor approached the NDSU Mechanical Engineering Department with design constraints looking to create an ergonomic intelligent food pad, which consolidates a cutting board, scale, scanner, and food baskets into a portable device at least 8 by 14 inches. These concepts show a cutting board supported by a frame with extendable legs to reduce its workspace footprint. It can then be placed over a sink while simultaneously being able to use a barcode scanner to identify a product and a scale to determine its mass before being placed into the baskets. This concept was ultimately chosen because it met the constraints and included knife slots and a movable scale interface. The concept cutting board and frame shown needed a design change to be manufacturable, which resulted in our final design that was broken down into 3 separate assembly processes: the frame, the cutting board, and the electronics. The welded aluminum frame houses 4 acetoplastic sleeves to guide the steel arms into the chassis. Each arm is capped with an acetal slider and a bolt to prevent the arms from falling out. The cutting board is then held in place by 4 vertical pegs so that the electronics can move without worry. A Raspberry Pi miniature computer with a touch screen was equipped with a USB barcode scanner and wired through an amplified analog to digital converter to a load cell to provide working information during the use of the device. To create a water-resistant casing, the Raspberry Pi has 3 separate cases: a screen case, a wiring case, and a steel housing. The steel housing, electronics mounting plate, and scale pan were all clear-coated with Flex Seal, which is food safe, and any holes in the back of the housing were filled with silicone. The assembled prototype is shown here with a knife in the holder and the Raspberry Pi turned on. The code runs in the terminal using Python and can currently be accessed using a Bluetooth mouse and keyboard, but in the future the barcode scanner and database can be offboarded to an app to further improve usability. Testing the food pad consisted of scanning barcodes that we had logged into a free online UPC database to prove the concept. Deflection was a factor considered during the initial concept selection, but due to the redesign of the frame, there was negligible deflection when cutting on the board. A separate program was then executed to show the scale taking the mass of potatoes in grams, and is limited to 5 kilograms. Parker and I would like to thank Dr. Vold, Dr. Quadir, and the ME department, as well as a few others listed here. This project was completed with the help of our late teammate, Kvien.